We ask ourselves this question: what does it ask of the underlying hardware machine? And if we were to optimize a machine for this work, could we make it? Fly Nvidia just lost $600 billion in market value, its biggest drop ever, and it's all because of one breakthrough. A new AI chip just crushed Nvidia's GPUs, outpacing them by 57 times in AI performance. This is a complete shift in AI computing, one that could redefine which companies control the future of artificial intelligence. At the center of it all, DeepSeek R1, an advanced AI model that's been making waves for its reasoning capabilities. But while DeepSeek has been causing a stir, the real disruption is happening because of Cerebras Systems, a company that just proved GPUs might no longer be the best option for AI. Cerebras' new wafer scale AI processor is delivering 1,600 tokens per second, running DeepSeek R1 at speeds that Nvidia's GPUs simply can't match. If you thought GPUs were the backbone of AI, this might change everything. But what exactly is DeepSeek? Why is this AI model causing so much panic? And how did Cerebras manage to outpace Nvidia based by such a massive margin? Let's break it all down. For years, AI models have focused on generating text, images, and code based on patterns. But DeepSeek R1 is different. It specializes in reasoning instead of just predicting the next word in a sentence. It processes multi-step logical tasks, making it far more advanced than traditional models like ChatGPT or Gemini. It's built to solve complex problems, analyze information, and provide deeper insight skills that could transform everything from research to corporate decision-making. But what's even more surprising, DeepSeek's efficiency. According to reports, it operates at just 1% of the cost of US competitors, while companies like OpenAI and Google are spending billions to refine AI. DeepSeek has found a way to achieve similar performance with significantly lower costs. That's why DeepSeek has been rapidly gaining attention. But there's a huge problem, one that's kept many companies from adopting it. DeepSeek is developed in China. This means that any company using DeepSeek's API is sending data straight to Chinese servers, given ongoing concerns over data security, government regulations, and geopolitical tensions. This has made many businesses hesitant to use it. This is where Cerebras comes in. The company has found a way to host DeepSeek R1 entirely on US servers, keeping sensitive data within American borders while offering unmatched AI speed and efficiency. But how is Cerebras pulling this off? The answer lies in its breakthrough AI chip, a piece of hardware that's fundamentally different from Nvidia's GPUs. How Cerebras just broke AI speed records for years. GPUs have been the backbone of AI computing. Nvidia's chips dominate the industry, powering everything from ChatGPT to Midjourney. But while GPUs are undeniably powerful, they come with a fundamental flaw. They weren't originally designed for AI inference. Traditional AI workloads require immense memory bandwidth and ultra-fast data transfers. GPUs built for graph-graph processing struggle with these demands, leading to bottlenecks that slow down AI computation. As AI models grow more complex, these limitations become even more apparent. Cerebras has tackled this problem with an entirely new approach. Instead of using clusters of smaller chips like GPUs, the company developed the world's largest AI processor on a single wafer-scale chip. This design eliminates the inefficiencies caused by transferring data between multiple GPU units, allowing entire AI models to run on a single massive processor without delays. The result: a dramatic speed boost when running DeepSeek R1. Cerebras AI processor achieves 1,600 tokens per second, compared to just 28 tokens per second. On Nvidia GPUs, that's a staggering 57 times increase in speed. And it's not just about DeepSeek. Benchmarks show that Cerebras wafer-scale technology outperforms OpenAI GPT-4 and other leading AI models across multiple key areas, including mathematical reasoning, complex question answering, and AI coding tasks. Even when compared to Grow, another company specializing in ultra-fast AI inference, Cerebras is still 6 times faster against traditional GPU-based solutions like Nvidia. It's nearly a 100 times faster. With such a massive performance leap, one question remains: if this technology is so superior, why hasn't Nvidia responded? The $600 billion meltdown the AI industry runs on hardware, and for the past decade Nvidia has dominated this space. Companies have spent billions on Nvidia's GPUs to power everything from AI research to self-driving cars. Their chips have been the default choice for machine learning and artificial intelligence, making Nvidia the most valuable semiconductor company in the world. But the emergence of DeepSeek R1, combined with Cerebras, his ability to run it at record speeds, has shaken investor confidence in Nvidia's dominance, as news broke that DeepSeek was outperforming models from OpenAI, and Google investors realized that GPUs might not be the best option for AI computing anymore. The market reacted instantly, and Nvidia's stock saw its biggest value loss in history, $600 billion wiped out. This signals a much bigger shift in the AI R&D industry. For years, Nvidia relied on the assumption that GPUs were the only viable option for AI workloads. But now companies like Cerebras are proving that dedicated AI chips are faster, cheaper, and more efficient. Specialized AI processors are showing significant performance advantages, challenging the GPU-centric model that has dominated AI infrastructure for years. This isn't just about one AI model or one company. It's about the entire future of how AI is run. If GPUs are no longer the go-to choice for AI inference, Nvidia will have to pivot quickly or risk losing its stronghold on the AI hardware market. So, what does this mean for Nvidia's future? Can they adapt to this new wave of AI hardware innovation? Or are we witnessing the beginning of a major shift away from GPUs? And more importantly, what does this mean for the future of AI itself? Data sovereignty and the US-China AI battle. AI adoption isn't just about speed and efficiency anymore. It's about who controls the data. With growing concerns over data privacy, government surveillance, and cybersecurity, many businesses have been hesitant to integrate Chinese AI models into their workflow. The issue isn't just theoretical. In recent years, US lawmakers have cracked down on Chinese technology over concerns about data misuse. ByteDance, the parent company of TikTok, has faced repeated scrutiny over how it handles user data, leading to multiple bans and legal battles. The same concerns now apply to AI models, like DeepSeek. This is where Cerebras changes the game by hosting DeepSeek R1 entirely on US soil. Cerebras is bypassing China's control, giving companies a way to access DeepSeek's powerful AI capabilities without security risks. James Wang, a senior executive at Cerebras, described it as taking back AI supremacy, suggesting that while China made major advances in AI, the US now has an opportunity to reclaim leadership in the space. And this isn't just about business, it's about global AI dominance. The AI race is no longer just about who builds the fastest models. It's about who owns the infrastructure, who controls the data, and which country sets the rules, with companies like Cerebras, OpenAI, and Grow developing cutting-edge AI chips and hosting solutions. The US is positioning itself as a leader in AI innovation without reliance on foreign technology. But the bigger question remains, are GPUs still the future of AI? Or is this the moment where specialized AI chips take over the future of AI chips? For years, AI development was built around GPUs. Companies spent billions of dollars acquiring Nvidia's chips, believing they were the only viable option for training and running AI models. Nvidia's dominance in the AI space seemed unshakable, with its GPUs powering everything from research labs to large-scale AI deployments. But Cerebras just proved that might no longer be the case with its wafer-scale AI processor. Cerebras has shown that specialized AI chips can be faster, more efficient, and cheaper than traditional GPUs. Rather than relying on clusters of GPUs that create memory bottlenecks, Cerebras' single-chip architecture eliminates inefficiencies, providing a significant speed boost for AI inference. And it's not just them. Tech giants like Google, Amazon, and Microsoft are also developing their own AI-specific processors, moving away from the Nvidia-dominated GPU ecosystem. Google has TPU's tensor processing units, designed it specifically for machine learning workloads. Amazon has Trainium and Inferentia AI chips built for cloud-based AI inference. Microsoft has Maya AI chips built to power its own AI ecosystem. The shift is clear. AI is moving towards specialized hardware. So what does this mean for Nvidia? If AI companies stop relying on GPUs, Nvidia could lose its biggest market right now. The company still dominates AI training, but as AI inference becomes more efficient and widespread, companies are looking for faster and cheaper alternatives, and the competition is moving fast. In just a few years, Cerebras grow, and other AI chip startups have leapfrogged GPUs in performance. If Nvidia doesn't pivot soon, they could find themselves losing ground in the AI space. But can they develop a competing AI-specific chip before these newer companies take over? That's the billion-dollar question. One thing is clear. Nvidia is no longer untouchable. For years, GPUs were the default choice for AI, powering everything from ChatGPT to Tesla's self-driving cars. Their dominance in AI computing was unquestioned, with billions poured into GPU-based infrastructure. So what happens next? We're about to witness an AI hardware arms race. The US-China AI competition is accelerating, with data sovereignty becoming a key issue as AI capabilities advance. The question of who controls the technology and where data is processed will become even more critical. If you've made it this far, let us know what you think in the comment section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.